So this section is going to be on our negative side waterproofing systems, coating systems that are installed from the negative side of an area to prevent ingress of active water leaks and liquid water as well. So when we discuss negative side waterproofing, a lot of times it's just thought as, oh, it's always the inside of a space. Well, in an area like this in a basement, yes, the positive side is the side where the water or the leak, the outside would be compressing the coating against the wall. The negative side is the side that faces the ingress, where we'd have a tensile pull off of a coating on the structure. But if we look at something like a water tank, where when the tank is full, the positive side is on the inside of the tank and the negative side is on the outside. We discuss water tanks, swimming pools, things like that. There are circumstances where both sides of the area, depending on the conditions, could be both the positive side and the negative side, again, depending if the tank or the pool is empty or full, or how high the water levels are on the outside. So again, we're discussing some of the requirements for an installation and solutions that we can offer. So the products that we can use to waterproof structures from the negative side are as follows. First of all, to prepare the substrate, we need to make sure that we have a clean substrate. So all of our any coating or any system we install is well bonded. So we clean the substrate to ensure that it's dust free and will get a good bond with the coating system. Stopping active leaks, larger kind of single source leakages where we have one area that's potentially gushing water. We'll use the KOSTER water stop. We'll go through during the presentation all of these products in themselves. Smaller areas with small widespread leakages, the KD2 Blitz powder is a product that is instantly reacting hydraulic cement product that we can use almost as a rub over weeping areas. We can also use it over smaller widespread leakages, or it can be used over single source leakages as well. To level a substrate with holes any deeper than like 1/4 inch or 5 millimeters, we use the KOSTER Repair Mortar or Repair Mortar Plus. And rounding out edges or installing fillets or cant strips at wall floor junctions or any kind of termination, we also use the KOSTER Repair Mortar or Repair Mortar Plus. Treating leaking cracks and joints is another ball game that we cover in a different presentation on our injection systems, specifically crack sealing and crack injections. Actually installing the area waterproofing over dry or wet substrates, we can use the KOSTER NB1 Gray. Over really heavily moisture burdened or really badly leaking substrates, we have the KOSTER KD system that can be used as well. Two different systems that each has their own purpose in installation. Most installations are much better suited for the NB1, but we will get into the difference in where we would use which product there. In terms of preparing the substrate for our installation, the concrete must be sound and solid, free of any kind of grease, oil, or any substance that will inhibit bond. It must be absorptive and open pored. Again, free of silicate sealers, waxes, or any kind of silicate curing compound that again prevent absorption and penetration of any kind of system into the concrete. No very wide gaping cracks. Any kind of offset or protrusion should be kept to a minimum. We want to work on a relatively smooth area or a relatively flat and level area. Testing for absorption, the easiest test, the poor man's test, is the water droplet test. So we can wet the substrate. If that water doesn't beat off the surface and roll down, but absorbs into the substrate and distributes itself into the wall or substrate, we've got a good absorptive substrate. If the water beads off and rolls down the wall or rolls off, then the substrate is not absorptive. Again, testing for pull-off strength and the quality of the tensile strength and the potential tensile bond strength of the substrate. Pull-off strength for concrete should be at least 200 psi to define the negative pressure rating of the system. So the weak point of any kind of system that's built is going to be the tensile strength of the concrete itself. It's not going to be the bond strength of the system to the concrete. Normally that negative pressure rating is the tensile strength of the concrete itself. The most commonly used methods for cleaning the concrete or cleaning the substrate, excuse me, are either by water jet, high pressure water jet, sandblasting, or grinding. Commonly sandblasting or water jet and pressure washing or high pressure washing are the most commonly used approaches. Again, you can see the substrate being washed on the left, and on the right, we've exposed the aggregate and we've removed that cement paste, and we have an open pored, porous, aggregate filled substrate that's ideal for our coating adhesion. Any defect that's less than 1/4 of an inch or 5 millimeters can be just filled with the MB1 by itself. Anything deeper, any holes, voids, any broken mortar joint or anything like that, that's deeper than 1/4 inch should be filled with repair mortar or repair mortar plus to even out the substrate. Stopping active leaks. So again, before any kind of area waterproofing can be installed, before a coating is installed, we need to stop the active leaks first. Try to install a coating over a system that's actively leaking. It's obviously just going to wash away any kind of coating that you install. So here we would install the KOSTER KD system using the KD2 Blitz or the KOSTER water stop. So here's a video here of the KOSTER KD2 Blitz. This is a very, very highly reactive powder with a very, very short setting time, reacts in about 5 to 10 seconds. It's not like a normal hydraulic cement that you'd mix with water. This reacts instantly with water. You can see here he's forming the ball of material in his hand, goes up, and it's used to stop the active leak. Again, this is used just to stop active leaks and either gushing leaks. You can see as it's installed as a powder, it's used almost more, it can be used as a widespread rub over wider leaking areas, but it also is very handy for stopping any kind of active leak. Very, very highly reactive product. Here we have the KOSTER water stop, which is a fast setting, expanding plug and repair mortar. Which is used, this is more of your hydraulic cement with about a 30 to 40 second reaction time. So it's used, you mix this with water. For single source leakages and for things that are more oddly shaped, this is easier to form the material into a ball or the shape that you need and force that into place before it reacts. Again, it's expanding a repair mortar that's used for these active leaks. So we'd mix the material and turn it in hands to work the material. Here, the picture on the right, we have that really, really severe active leak. You can see he's formed a ball of material in his hands that he's ready to use to pack in that void. It's installed it's thrown into place over the leak, held in place for about 20 to 30 seconds for it to react. And then we have, again, a sealed active leak. So we've used either one of these products to instantly stop any active leak in the substrate, to allow us to install a coating system over the top. When we install any kind of waterproofing system like this, we always want to ease transitions. So at the 90-degree angles at wall floor junctions, we always install a fillet or cant strip of repair mortar or repair mortar plus. These cant strips are usually 2 to 3 inches, either coved or triangular. When we do this, we have an additive that we'll discuss some of the accessory products, but the SP bonding emulsion is normally used in this application. It just increases the workability of the product. It's a styrene butadiene emulsion that aids in curing of these products, increases the compressive strength, and improves the workability of the materials themselves. So again, so we can have cove base that's diagonal or a radius cove base, depending on the whatever specification or on the applicator's preference. So in terms of area waterproofing, there are 3 systems that we can go with for area waterproofing. First, KD system. Second, the KOSTER NB1 gray system, and obviously we can use a hybrid combination of the KD system with the NB1. The KD system is a very fast reacting system that's used in smaller, more worn down areas where the NB1 gray is kind of more of an all-purpose. And we'll discuss the difference between the two again when we get to more of the specifics. The KD system is made up of 3 components: KD 1, 2, 3. The KD 1 is the base. It's a very fast reacting slurry that's installed with a brush onto the substrate with very high resistance against ground moisture and pressurized water. The KD 2 is the blitz powder that we saw previously installed. that's used as a very highly reactive powder. KD3 is a solidifying low viscosity liquid. It's a silicate sealer that's sprayed on over the system. So the way the system is installed is the KD1 base is installed as a slurry over the substrate. The Blitz powder is used to rub in and hydrate the wet slurry. The KD3 sealer is either brushed or sprayed onto the surface, and we get 2 more installations of the KD1 base to build the body of the system. Waterproof against pressurized water up to 100 psi, fast application. It's very resistant to efflorescence and any kind of crystal growth or anything like that. But it is a 5-coat installation. Again, when we talk about the difference of where we would use the KD system, where we would use the MB1, if you have 5,000, 7,000 square feet, you're never going to be installing the KD1 base. This is for really heavily burdened, salt burdened, and very badly leaking substrates. Again, more commonly than not, masonry, that we need to go in and do a fast repair where there's only maybe an hour or it's a very short period of time to get in and get out and install this system in an isolated area. It's very hard to install this 5-step system in phases over much larger areas. So again, this is more for like more isolated areas than the NB1 would be. The NB1 is like I said, the much more popular product, capillary crystalline cementitious coating. That's watertight with up to upwards of 430 feet of head pressure. It's mineral waterproofing with crystallizing agents. This is what we call our capillary crystalline coating, where these crystals form in the capillaries of the concrete and block moisture intrusion that way. NB1 gray can be used for both positive side and negative side waterproofing, primarily against moisture ingress, including pressurized water. Waterproof against pressurized water up to 200 psi from both the positive and negative side. These systems are designed to be rigid coating systems. They have a very high compressive strength. They need to be rigid on the negative side because negative side coatings, like we said, if water is coming through that wall, that water is weighing on and trying to push that coating off the wall. So the tensile bond strength, first of all, must be very high. But also, if we use any kind of elastic coating, that may be breached due to high pressure behind the wall. So the rigidity is very important to ensure that we don't get a failure of the system. Can be used over brick, concrete, shotcrete, CMU, almost any masonry substrate. Can be used in restoration or also in new construction, obviously. This is certified for use in drinking water environments as well. In drinking water tanks, it can be exposed to drinking water. How does the system work? First of all, the NB1 spray penetrates into the pores of the concrete, creating obviously an excellent bond to the substrate, becoming integrally part of the substrate. The cured coating, again, is resistant to salt crystallization, efflorescence, and water pressure, and has a very, very high pull-off strength. This is a schematic of obviously not real-life application, but when the NB1 crystallizes, fills the pores and capillaries and voids in the near surface region of the concrete, becomes an integral part of the structure due to its formation of these crystals. And then as that coating penetrates into the pores, the slurry as it's installed penetrates into the pores. The alkaline silicates and latent compounds in the slurry react with calcium hydroxide and moisture in the concrete itself, so free lime and moisture in the concrete to form these CSH calcium silicate hydrates. These are the crystals that are the reaction product, and they plug the pores of the substrate. There's obviously a chemical resistance, and water cannot enter these plugged pores and cavities and voids, so it blocks water ingress that way through the formation of these crystals. Again, the big thing is coming from the reaction of the slurry itself with the free lime, the calcium hydroxide, and moisture that's in the concrete itself. Finally, we talked about the SP bonding emulsion. The coating can be modified with SP bonding emulsion. Up to 20% of the mixing water can be substituted, which adds some flexibility and workability of the system itself, but also during curing it has that positive effect to prevent premature drying out of the fresh coating by creating kind of an internal curing compound. If we're going to be painting over the system. So breathable paints can be installed over the top of the MB1. It is a breathable, permeable system. SB bonding emulsion should be used in the second coat to ensure that there's no salt growth or crystalline growth where we're going to be painting over it. Preparation again. So we talked about cleaning the concrete or cleaning the substrate to remove any kind of dust or previous coatings or any kind of compounds like that. Concrete or normally absorbent substrates can be saturated with water to an SSD condition. Any kind of highly absorbent masonry substrate, we always prime with our PolySeal TG500, the silicate primer that compensates absorption of the substrate, but it also binds salts and blocks efflorescence from forming on the surface of the concrete after it's been primed. Again, our goal is that the substrate doesn't absorb any water from the wet coating. If the substrate absorbs water from the wet coating, there may not be enough water in that slurry to properly hydrate and cure as it has to. 9 times out of 10 too, where we say, oh, we can either prime to we can dampen to an SSD or we can use the PolySeal. 9 times out of 10 we're using the PolySeal just because, first of all, as it's installed and the wall's primed, it's ready to be sealed over in about a half hour, and it doesn't have to be reprimed within a couple days. When we saturate the substrate with water on a very hot day, or if there's large areas, by the time you've saturated and you've worked your way down to the end, by the time you get back to the start, you may need to re-dampen that substrate. When we prime with the PolySeal, there's no need to re-dampen or reapply. It doesn't dry out like water dries out. So the PolySeal is normally used in every application, but the PolySeal is always required in masonry applications over CMU, block, brick, anything like that. The PolySeal is also recommended over concrete, but it isn't required over concrete. PolySeal is required, the SB bonding emulsion is required over any application over brick, block, or CMU or any kind of porous substrate. It's mixed by hand with a mechanical mixing device, a normal mortar mixer. So it's mixed. 1 bag of MB1 is mixed with either 8.5 quarts of water or 6.5 quarts of water and 2 quarts of SB bonding emulsion, like we discussed. It improves the workability of the slurry and that internal curing compound that we talked about. A portion of that bonding emulsion migrates to the surface of the coating and forms of skin, reducing the evaporation rate and aiding in the curing of the coating itself. So it doesn't just increase the workability; it also increases helps create a curing compound as well on the coating itself. Obviously, so when we mix this material, we're going to end up with a slurry consistency. This is normally installed with a mason's brush. So we want that real slurry consistency. Again, we can install the product with a brush. This can also be sprayed using any kind of peristaltic or carousel or rotostator pump. Most commonly, it's installed by brush. Just a standard mason brush will suffice. During installation, brushing is done in both directions, so up and down and side to side, to make sure that all the holes are closed from all sides. Normal installation is 2 coats, each at 30 mils, for a total installation thickness of 60 mils, which is about a 1/16 of an inch. And again, in both coats, you want to make sure that you work the material in both directions to ensure that there are no holidays, voids, or missed spots, or any holes left through the system. Again, the coating can be sprayed using our KOSTER peristaltic pump or any kind of rotostator or carousel pump. When it's sprayed, it can be finished in, can be installed in 1 coat of 60 mils, but after spraying, it should be worked in and finished, knocked down with a wood float or a magic trowel or a mason's brush just to close everything and knock it down. Again, going over the 2 different products themselves. KD system, we have that high resistance to pressurized water up to 100 psi, fast, easy application, very resistant to salt efflorescence. Again, these are more on, this is more for application in brick and masonry substrates that have really been broken down by salt growth and constant exposure to moisture, and have really failed due to more of the exposure to salts, because this does provide a great protection against salt efflorescence and crystal growth or anything like that. Again, we can use the KD2 Blitz as part of this system to seal those active leaks instantly. And we do use 3 products here, 5 coat total systems. We use the KD1, KD2, the KD3 sealer, and then 2 more coats of the KD1. The NB1 system can be used positive and negative side for pressurized water conditions. Again, we have that really, really rigid, high compressive strength coating with that really, really high tensile bond strength in the wide range of substrates, brick, concrete, shotcrete, and CMU, among many others. And again, used in new construction and restoration products as well. It is certified for use in drinking water environments. It's only certified for use in drinking water environments if the SP bonding emulsion is not used. If the product itself is mixed with water and installed, we have certification, NSF certification for exposure to drinking water. If that SP bonding emulsion is used in the mix, we don't have that certification currently for drinking water exposure.